Okay, so today we're going to be solving this statics problem. It's about a ladder in an aqueduct. So to solve this, we're going to have to draw a free body diagram with all the forces labeled and all the angles labeled. Once you have all the angles labeled, it's just a geometry problem. You basically have to balance all the forces and all the moments in order to get a value for the theta in this case, which is the inclination, which is what we have to find. So if we take moments about A, we will have this force, this mg, acting clockwise, while this R2, reaction 2, will be acting anti-clockwise. But because it's balanced, they're gonna be equal. So if we write the equation, we have mg cos theta is equal to 2 R2 sine theta. No, sine 60, sorry. Anyways, so we have the 2 over here because you can clearly see that the mg is acting at the midpoint while R2 is acting at the end. So you can tell that the distance is doubled. So we have to add the 2. In this case, we know that sine 60 is equal to root 3 over 2, which cancels with the 2. So we have that cos theta is equal to root 3 R2 divided by mg. This is our first expression. Now we will also need an expression for R1 and sine theta. So to do that, we're going to resolve the vectors in this question and balance them in this direction, so perpendicular to the ladder, and in this direction, horizontal to the ladder. So to do this, we're going to have to resolve the angles. So first, we're going to resolve them perpendicularly. So to do that, we have this one and this one, which act opposite to this one and this one. So we have, because they're the same angles, we can group them. So I have sine 60 R1 plus R2 is equal to, because they're the same, they're both the same, is 2mg cos theta. Okay, so solving this, if we just like rearrange for cos, we know that sine theta again is root 3 over 2, over the 2 over here. So if we divide that, we have that cos theta is equal to root 3 R1 plus R2 over 4mg. Okay, so from this, we can compare this to this equation. Because they're both cos thetas, we can just equate the two equations. In this case, we have root 3 R2 over mg is equal to root 3 brackets R1 plus R2 over 4mg. Okay, so here we can cancel out the mg's, just multiply by mg, divide by root 3. Okay, so we have that R2 is equal to R1 over 4 plus R2 over 4. So if we group them, that over 4 equals to R1 over 4. So then we cancel, and we're left with R1 is equal to 3R2. This conclusion makes a lot of sense because the man is standing at A. That means there's going to be more pressure here, more force acting downwards here. So R1 is clearly going to be bigger than R2. So this conclusion that we got here makes logical sense. Anyways, we have our equations for the relation. We have the relationship between R1 and R2, and we have an expression for cos theta. Next thing that we're going to do is, let me move this, is resolve the vectors not horizontally, saying parallel to the ladder. So to do that, we're gonna resolve the angles from this way and this way. So to do that, we know that this and this act in opposite ways, and the mg, they're both acting downwards. So again, we have 2mg sine theta plus r2 cos 60 is equal to r1 cos 60 as well. Wait, space. Okay, cos 60. Okay, we know that cos 60 is a half, so that's simple. So we have 2mg sine theta plus r2 over 2. And we know that r1 is equal to 3r2, so let's put that there. That's 3r2 over 2. So this was left with. So then if we pass that, we collect like terms, and then we divide. So we get sine theta is equal to r2 over 2mg. Okay, so now we have everything we need to find out theta. We have this and this. Now clearly what we can do is just get tan. So we divide sine by cos. So in that case we get tan theta is equal to R2 over 2mg over R2 root 3 over mg. Okay, so we do mg cancels, R2 cancels, and we're left with 0.5 over root 3. When we put this in the calculator, we get approximately 16.1 degrees. And this is our final answer, which is a reasonable answer since it's a very small angle. We can tell that it's going to be very small from the diagram. So yeah, that's our final answer. This angle right here is 16.1. Y se acabó. The following question is a very simple and fun question. There is basically no math involved and it's mostly conceptual. If your physical fundamentals are correct, you're going to be able to solve this question pretty easily. So for an n-sided polygon, let's take any polygon. I'm gonna choose a square because like squares are quite easy and simple to draw and to work with. But you can work with anything because you're gonna realize that it doesn't matter later on. So the only forces acting on this is gonna be a weight, so mg, and the force applied to the axle, which we're gonna call F. Okay, so how you can see, I drew a circle around it to show you that if we have this is the distance. This distance here is gonna be r. The diagonal is always going to be r for any n-sided one because any n-sided regular polygon can fit in a circle, and the diagonals are always going to be r. Okay, so anyways, so we have the distance r, and now we have this angle here theta. Because it's a square, we know that this theta is actually going to be equal to 45 degrees. But let's forget that for now. Let's generalize. We have this angle theta. So what we know is that to make this square rotate, not slip, because slip is just F. There's no force counteracting. We have to make it rotate. So in order to make it rotate, we're gonna have to use moments. So if we take moments about this corner right here, let's call it A, and moments about A is going to be equal to R. The distance is the same for both forces. We're gonna have mg. Sorry, I can type mg sine, because it's opposite. It's gonna be acting this way, like right here. So I have mg sine theta has to be equal to F force right here, which is going to be opposite to it, which is going to be cos theta. So F cos theta. So from this, we can tell that F is equal to mg tan theta. So this expression right here, right? Sorry, this expression right here is valid for any n-sided polygon. Any of them, it's always going to be the same. The distance is always the same, and the only thing that changes with the sides, with the addition of sides, is the theta. So we know that this is 45 degrees. This theta in this example is 45 degrees. But how do you generalize this? So to generalize it, we know that a polygon is n sides. So let's say 4 sides here. We can make 4 diagonals, 4 r's, because it touches like there is 4 vertices. So there is n vertices at the circle. So we know that this makes an angle of. So we know that this separates. Sorry, separates not an angle. It separates the circle into 4 sectors. So we know that each sector is going to be 90 degrees, or pi over 2. We know that. And this is the same for anything. So we have that, let's say a triangle, it separates it into 3 sections. So this, and this, all 120. Or 2 pi over 3. So how you can see the pattern is that we have 2 pi, because that is the entire 360. That's the entirety of the circle. That's the whole circle. And then we're going to have to separate it into n. And that's what we're going to separate into. But we're not, this angle here is not this. It's going to be half of it. You can see, because it's true that it separates it into n sides, into n pieces, but we only take half of it. So it's perfect. So we just have to divide by 2. So we know that 45 is also equal to pi over 4. So what we do is that we know that angle theta is equal to 2 pi over 2n, also equal to pi over n. So that's the answer. So to answer the solution, it's asking what happens as n tends to infinity. So as n tends to infinity, this becomes much smaller. It becomes much smaller. It becomes infinitely smaller. So we have that it approximates tan 0, and tan 0 is equal to 0. So we can see that as n tends to infinity, the force F tends to 0, because tan becomes increasingly smaller, meaning that F also becomes increasingly smaller. So this is why circles can the most effective shape, because you basically need no force to maintain it rotating. The tiniest little push is gonna make the circle rotate.